experience. So hopefully it's changing you as a person too.
I think so. I think this is an absolutely an inspired Dr. Ballard moment. He spoke at my school and said that we're moving spirits. We can't get everyone down to the deep earth, but we can get everyone to view it and share it and see that experience of excitement and exploration. And I think that I certainly feel that. It sounds like a lot of you guys out there feel it, and our team here as well. We're just incredibly excited to be a part of something that just continues exploration and continues asking questions and just opens our minds up to so many more things. So I think that was great answers, you guys, and I'm so excited to just keep going and being even more excited as we continue this journey, because I'm not gonna lie, I love this. Okay, so we are looking at some more questions. We are looking at the seafloor right now, so it's changing a little bit in slope, but this is the seafloor. It's got sort of that clay muddy sediment we were just talking about. Does water freeze at different temperatures depending on pressure? Yes, it does. I don't remember the precise curve, so someone can correct me, but I'm pretty sure as the pressure increases, it's harder to freeze. Is that backwards?
Oh gosh. You're stretching our memories.
I'm just stretching my own memory. There's a curve there somewhere. Yeah. Somebody might have to go get the chemistry book. But yes, I can tell you the answer to that is yes. How it does it, we're going to Google that one.
So okay, piecing together, looking at, I remember these temperature, salinity kind of pressure diagrams.
Right.
And so when you have lighter pressure, then you have a higher vapor point, so you have more gas able to form, which must mean that under deeper pressure, greater pressure, it's harder for a gas to form and potentially easier for a solid to form. But I don't know that that's totally true for a liquid to a solid. What I do know, and what I'm just going to say, because I think this is something that we don't often think about unless we're physical oceanographers, seawater can get below freezing. The ocean water around Antarctica is about -2 degrees, and it gets to be about negative 1.7 degrees, because at -2 it freezes.
At Celsius.
Celsius. Oh, yes.
But that's salt water.
So that's salt water, so that's it. So salinity absolutely affects the freezing point.
But does pressure? Yeah, that's the question.
I'm pretty sure pressure does. You know what? We're just going to Google this and find out.
We've gone retrograde. We've gone retrograde.
It's interesting, those pock marks in the clay here on the side.
I mean, it almost looks solid.
Yes, although there's nothing growing on it. So I'm gonna say less likely to be solid, because we don't have sponges on it or tube worms sticking out off of it.
So the feature that we're traversing is a fairly steep slope that showed up in mapping that was done of this area previously. And the hope was that there would be rock along this escarpment that would perhaps be the location of additional octopus gardens. But so far it's a very interesting but not very populated area.
So there are a couple black corals. Those are Bathypathes.
Yeah, a lot of what we're seeing is very similar to what we saw in the octopus gardens that were at this depth. How far away are we from that? Nautical miles?
How far are we from the octopus garden? A couple kilometers, not too far.
Miles, are you able to figure that out with your nav screen?
Yeah, stand by.
All right, while we're waiting on those nautical miles, I do want to confirm our chemistry question for the afternoon. If you increase the pressure, you decrease the freezing point of water. So
Okay.
not only do you have super salty water, you have increased pressure. So that's going to make it even harder to freeze that water.
We are almost exactly 1 nautical mile away.
One
Okay.
nautical mile away.
Save
I
I would
1 meter.
interpret
Wait.
that
It makes me think about
differently.
methane.
1 nautical mile.
You're going to interpret
One-
that differently?
Thank
If you increase
1
the
nautical
freezing
mile away.
point,
Exactly.
that means it doesn't have to get as cold
1852
to freeze.
meters.
Oh, you said increase the freezing point. Because I'm thinking of methane hydrates and how methane is a gas when we're at ambient temperature and pressure, but in the deep sea you can end up with methane forming a solid.
Oh, I
If,
have.
if you
Under higher
decrease the
pressure.
freezing point, it
Mhm.
freezes at a lower temperature.
I would agree with that statement.
Yes.
Oh, so I said it backwards.
So if you
Right.
increase the freezing point, you make it easier to freeze.
Correct.
So increased pressure increases the freezing point, according to Danny's research. Correct?
Yes. Yes. Let me double check if I can work this computer.
No,
Let me double check
But
that.
we don't see freezing water at depth.
No.
No. Let me look at this beautiful chart because I am much more of a visual learner than reading. Come on, beautiful curve of water freezing. And yes, I hear everyone on Nautilus Live sending me PivNert. I gotcha. You are correct.
for
PivNert
gases.
can 100% figure this out for us.
isn't PivNert for ideal gases, which means standard temperature and pressure?
Yes. Yes, it is.
So this is under extreme pressure. I don't know if PivNert will do
Yeah, so usually, but you can, that's true. You could swap out that one ATM for what we're working with, but I don't think it would stay on that curve as well. So you'd get a number, but not quite as accurate. It's like increase pressure and decrease. I'm sticking with my data that says where to go.
Hey, don't worry, we'll be going east at some point.
All right, where are the fish? Come on, fish. Erica loves the fish. I'm hoping
I
to
don't know, 'cause
see.
if you decrease the freezing pressure. No, if you increase the freezing pressure, decrease the freezing pressure, but you have
Black
salt
lines are
in your
50s.
water.
So this is 3,200. Thereabout. How many lines? There's
I wonder, are our viewers looking this up as well? Because Google's popping up a bunch of answers at the top of my thread, or at the top of my search that's related to things like, can pressure turn water into ice? And I wonder if we're really like hitting up Google Analytics and making this search a big search on it right now.
Just changing everything.
That's an urchin in the lower left corner as we're passing it.
Hi, buddy.
Bridge nav, another step north.
We've got a pycnogonid, one of those sea spiders moving along at the
Ooh,
bottom left of the
the
screen.
white one, right?
Yeah. So those guys exist in the shallow water as well. You can see them if you go out tide pooling, but they wouldn't be that big. There's a phenomenon in the deep sea called deep sea gigantism. There's also deep sea miniaturization. So really there's just weird sizes of things.
Can you tell us a little bit about how small the body parts are and where the...
Was that a flapjack?
Oh, I missed it.
I thought I saw that too.
Oh, what's this?
I don't know what that was.
That is a
Polychaete.
swimming polychaete, a swimming annelid worm.
Missed it. But isn't it true that sea spiders, their organs are down into their legs?
Yes, they don't have enough space or volume inside of their main body, so their gonads extend down into their legs.
Wow.
We have so many comments coming in. Thank you guys for your support and for how much Nautilus Live has meant to you. Lots of people are telling me to not trust Google. And don't you worry, I am looking at a phase diagram right now. My brain is just a little bit slow.
I'll just say
Oh,
thinking about
I
the
said it
physics
right.
of
Y'all flipped
molecules.
it in the discussion, says this person. So take that, you guys. I like that person. I am going to stick with me being correct. Thank you, human on the internet.
Thank you, peer review process.
Thank you,
Yeah,
peer
that's
review.
right.
Absolutely. This is why we use peer review. We had someone asking us about going to the Marianas Trench, and we don't currently have any plans to do that because at the moment, none of our ROVs are built to withstand that pressure. We can go to 40,000 meters, 400,000 meters.
4,000.
4,000
Can we
meters.
zoom on those two small,
You guys, I'm going to go take
I
a
think
nap.
there's an
I'll be
urchin
right
on the
back.
left
My
of the
numbers
screen.
no longer work.
slightly above the lasers and to the left? I think they're two
4,000
urchins.
meters is what the word should have said.
To what?
Or we can zoom right in the center. Either one. Seems like a
I'm
lump
ready
there
to
and a lump
zoom
there.
when Dan says.
What are we zooming on?
The urchin just below the lasers.
I can't hear you.
The guy dead center.
The urchin right below the lasers. There's like a
Copy.
bump.
Yeah. Zoom away. You don't have to wait for me, Wayne. I'm not particular.
See if it is or is not an urchin.
Well, let me correct that. Depending on the situation.
Yeah,
So, and this is like super benign and we're moving slow.
yeah.
You can zoom away.
That is,
That's an
or
irregular-
was,
Yeah,
is it living?
Mm-hmm.
that is an
Okay.
urchin.
Yep, that's an irregular heart urchin.
Oh, cute.
Was that the,
Great, thank you for the zoom.
what's the group name? Is that
Oh boy, Spatangida or something like
Okay.
that. But the irregular urchins,
Mhm.
I want to say I've heard them called spatangids.
Yes.
Are there regular urchins?
There are, that's
Tangents.
the ones that are fully round and symmetrical, or pentaradial symmetry. Those are called regular urchins. The irregular, they're more ovoid. Oh yeah, there's a regular urchin down to the bottom left. Just there for comparison.
All right, I'm bringing up this discussion one more time because we're going to figure it out. So because water is different than most substances, the liquid water is more dense than solid water, right? Because lots of people are reminding me, where's the ice at the bottom of the ocean? Yeah, that doesn't work. We got that. So if you have a salty solution and it's under high pressure, that seems like it would be much harder to form the matrix of something freezing. So I'm going to go with it's harder to freeze water the more pressure
yeah,
there is.
I'll step into it as we go north.
And we're going to go with that. We got some women of STEM encouragement.
Bridge nav, another step.
You are correct about Little Herc. Little Herc we're not using Little Herc at the moment. We are using Big Herc or just normal Hercules. But Little Herc will be able to go deeper. And send in more questions, you guys. Let's have another debate.
There's a sea pig right there. If you could do a quick zoom.
No more chemistry.
Back there to the left of the lasers, that's a sea pig.
A sea pig? Is
Two
it
sea
really?
pigs.
Yeah, one above
Yep.
and one to the left.
Oh, there's so many of them.
There's so many, 2 of them.
Okay, tell us more. What is a sea pig?
A sea pig is a sea cucumber, and they snuffle along on the seafloor and eat dirt and poop out just dirt, minus the organic material. So you can see all this darker stuff on the sediment. That's sunken down organic material from the surface, and so sea pigs will eat through the sediment and, is it pooping? No, darn.
Darn.
And they'll walk along and snuffle along and scoop up sediment with these arms that they have around their mouth called oral arms. So this guy's probably feeding on the dark material that's sitting on the top of the sediment there. And this form of feeding is called deposit feeding. There's just a paper published recently by Jim Barry and co-authors at Mbari that sea pigs often have an associated little crab living on the underside of them. So it's possible we'll get a glimpse of a crab that lives as a commensal with this guy.
There's a crab that lives under the sea pig?
Yeah, maybe
Yeah,
we'll see his belly.
Hold on.
Take
I
a
gotta
gallop
come
sea
wide.
pig.
What?
So most sea...
And they move with those
Yeah.
legs?
They do, yeah. So most
Or
sea
arms.
cucumbers don't have these big sort of appendages sticking out. This is some adaptation of the sea pig in particular. Oh, you can see the oral arms there to the front left.
Almost like he has fingers on the ends of his appendages.
They're claw-like, yeah.
It's really cute.
Do these count kind of as tube feet? Or are they
Uh-oh,
two? Oh no.
uh-oh, uh-oh.
Oh no.
You know what happens when a pig rolls over?
Oh, man.
Well, that really looks like a pig.
Terrible
You can see
dad
the oral
jokes.
arms right there. So those are all arms around the mouth
That
of the
is
sea pig.
sad.
And this guy didn't have a commensal crab living underneath
No
it.
crab.
He had a
Didn't have a
shrimp.
crab.
He'll get back
There's a
up.
little shrimp.
There
Yeah,
is a
that's
shrimp.
true. There's a
So-
shrimp.
I'm sure this happens to them.
He's playing possum
Yeah,
now.
right. They've adapted to flying ROVs.
Thank you for the zoom.
You're
What's that
welcome.
game where you roll the pigs in a cup of dice and they come out?
That's a game?
Oh, yeah, that's a fun game.
You guys, that's
this
not
one's
funny.
a leaner.
Past the
Goodness.
pig.
This poor sea pig.
So cute.
Yeah, look at those oral appendages. Wow.
We've uprighted him now.
Oh, yeah, we flipped it right back
Okay.
over. Perfect.
Thank you.
Thank you.
Yeah.
Good job.
Well, so that's amazing, right? I mean, I was imagining the close-up that we were right up next to it and somehow blowing him over. But no, we were actually quite a ways away.
I might
fell
have just
over
lost
all
He
my
just
footing.
fell over by himself.
It's pretty steep here. Do
Hey,
you
what's
have any
in
way of
that mud
estimating?
anyway?
He wanted to roll down the hill. He was just tumbling down the hill. It's
Hey,
a
hey.
sea
Yeah.
pig hobby.
That's right.
There's a
It's
piece
like-
of kelp.
Yeah, drift kelp being
With an urchin.
eaten by an urchin.
Yes.
Maybe eaten.
It's a snack.
Holding on to it.
Soon to be.
So this is evidence of the productivity that is transferred to the deep ocean from up high where the sun shines.
There's a little benthocodon, that dark jelly near the seafloor, swimming along.
Yes,
Oh,
right.
Moving fast.
Yes.
Okay, so the internet really wants to know what is one thing you would add to the Nautilus or ROVs to make research better, and what's one thing that you would do to make the lifestyle on the ship better and more fun and someone else would like to know how they quit their job and have as much fun as we do.
Bandwidth, more
you
bandwidth.
Yeah, more bandwidth for sure.
absolutely do that. More
We've
bandwidth.
clearly
Okay, so
taken
we
for
need
granted
more
the fact that we
bandwidth
have
for doing
bandwidth.
all of the things that we want to do.
Yes, 4 times as much on this boat as any other boat I ever work on. So, and I'm still complaining.
And we still want more.
But it is quite amazing that we have internet out here.
We do.
That's
Yep.
amazing.
First time I went on a ship, they gave me an email address that was specifically for the ship, and they uploaded emails and downloaded emails 3 times a day. No, twice a day. And we could only receive emails that were less than 1 megabyte in size.
Yes.
So it was like text only. So bandwidth has come a long way. It's pretty cool.
Oh, we certainly appreciate it. We would also like to request just like a little more. Ooh, hammocks. We had hammocks on the Nautilus. That would be lovely. That's a great idea. But we work a lot. It would be bad if we had hammocks. I think too many of us would just nicely fall asleep.
I'd get super seasick. I would opt for something like a beanbag. It's very stable.
Chair.
But no, and then the other question was, what would we add to the capabilities?
Yeah, so what's like one thing you would add to the Nautilus or ROVs to make research better? And then what's one thing you would add to make sort of lifestyle on the ship better and more fun?
I enjoy working with UAVs a bit more. And just having them on board to send them out and do the preliminary imaging of the areas, so when we do dive, we know
Can we zoom in on that
we're
grenadier,
maximizing our dive time by seeing something that's actually interesting.
Okay, can you
they're
describe a
AUVs on
UAV
in
a
the
little bit
SeaWorld.
more?
Is that fungus
Ooh,
on
yeah.
the
please?
dorsal?
Might be.
Yeah, stand by.
Was that a Grenadier?
It
Yes.
was.
Okay.
Yes. I got that one now. Fingers crossed.
That's good. Thank you.
Right, the cuskeel has a tail, right?
Okay,
Or a
full
little
wide.
stub of a caudal fin.
Yes, a little nub.
Yeah, so UAVs are
Wait, we use AUVs.
AUVs.
UAVs are for military purposes.
well, yeah,
Well,
Unmanned aerial vehicles versus autonomous underwater vehicles.
autonomous underwater vehicles.
Oh, I got you.
AUVs.
We heard what you meant.
Yeah,
I got
the
you.
AUVs.
It's for the internet.
Thank you for the clarification.
I think what I'd be really interested in is just something that I've heard talked about. I don't know if the technology would work, but it's in development to try to make a virtual reality, like wearing VR goggles so that you're able to use stereo cameras and see in 3 dimensions. I think that would be powerful, not so much for me as a scientist, although it would be very neat, but for the pilots, because whenever they're moving the manipulator arms, they're having to look at different cameras to be able to see all 3 dimensions and how the arm is moving. So I feel like our precision could get so tight.
I've used a vehicle that had stereoscopic cameras and glasses on 3D
Really?
on 3D monitors, and
They exist.
it's okay.
Oh,
Just okay?
It's just okay.
okay.
What's good and what's bad about it? Tell us more.
Well, at least on that vehicle, the front porch was full of science equipment, and so it was always in the frame of view, and
ooh, what
check
is
out
that
this
up
heart
there?
structure
Yeah,
here.
yeah.
didn't
Yeah.
Zoom in on
quite.
him.
It wasn't quite 3D at that.
Ready
close
for a
range,
zoom, Dan?
So you
Yes, please.
kinda
Let
couldn't
me
see the front
let me
porch.
get a little closer.
Is that a turtle?
Still
Okay.
moving it.
No.
Once the lasers get above it, Wayne, then you can do the laser zoom.
Sounds good.
This might
Sorry,
be
we were-
trash.
No, it's
can.
okay.
We were light years away.
Wow.
Trash.
Oh,
It is
no.
trash.
Is it trash?
Oh.
I see a books,
Yep.
That's so
tin
sad.
cans.
That
Tin
is
cans.
Wow.
tin cans.
Like
It's
a paint
weird
can
that
or
it's all
something.
sort of collected
Soda
in one
cans.
spot.
That
Yeah,
looks like one of
Paint
those
cans.
coffee cups. Oh no, that's a soda can.
Paint cans.
maybe a
Went through the
paint
crusher.
can.
It looks like aluminum foil crushed up.
Yeah.
Maybe a coffee
Well, some
can.
of it is. It's cans. I mean, they've still got the
They're all
paper
squished.
wrappers on them.
Human.
Wow.
we're the worst for the environment.
I think
Well,
I see a plastic cup.
Or styrofoam down there.
This is
Yeah.
why we can't have nice things.
Looks like
This,
There's one of those red
yes,
shrimp.
that is it.
Oh,
This
yeah.
is why we can't have nice things.
At least it was
We
in, not in a plastic bag.
Yeah. Well, maybe it started
Well,
there.
those
Ugh. That's just frustrating.
the anemone on top seems to have
Yeah,
appreciated the.
they don't mind.
The height above the seafloor.
Yeah, exactly.
There's another grenadier, sometimes called rat tail. This one I think is the abyssal grenadier called Corphonortes armatus.
And we see some more irregular urchins snuffling along in the sediments. They leave tracks behind. And so if you go out to certain places hiking, you can find trace fossils of urchin tracks and other seafloor animal tracks, like embedded in the rock. Erica's giving me a look. We have
Wow.
one nearby, Point Lobos.
Really?
Yeah.
Wow.
Point Lobos State Park has trace fossils. You can see little footprints, basically.
Huh. That's really good. Someone asked how the food on the ship was. It is delicious.
It's
we
awesome.
Oh,
actually
man,
do
yeah.
have a gourmet chef hiding in the mess. It's so good.
With a wonderful Eastern European touch.
Yes.
I mean, I love the chopped veggie salads. Oh,
so good.
man. Yeah. Mm.
So good. It is kind of weird for us to see a clump of trash like that. We have seen sort of bits and pieces, but I have not seen quite as big of a lump as that in other dives.
Yeah, I'd say it's pretty sad. On the last leg of
Yeah.
the last cruise, we saw quite a bit of trash too. I think what was it, Miles? You said like it averaged like maybe at least 2 or 3 pieces of trash per watch we saw
Per dive.
per dive.
Oh, my gosh.
For the entire West Coast.
Yeah.
Okay.
Wow.
Or at least Nautilus's West Coast career.
Yeah.
When we were out in the Central Pacific earlier this year, we were remarking at how we had not seen trash for a while.
Hmm.
Yeah, that looks like it was thrown overboard in a biodegradable container of
Yep.
some sort.
Yep.
And it reached the
No,
bottom all
but
in one clump, and then the
Liponita
bag
type,
or whatever just deteriorated.
but not liponita.
Yeah.
It's the only way to explain why they're so concentrated.
Oh, can you zoom on that urchin? That's right below the lasers.
I can. Dan?
Yep, go.
Okay.
What's hanging off of it?
Does it have a
The baby
Ooh.
cucumbers?
Tiny cucumbers.
worm? Tiny cucumbers?
Yeah,
Wow. And is that another one of the irregular urchins?
it is.
So we're seeing a lot of those here, aren't we?
We are, yes. Those are often things that you see in soft sediments. Cool.
There's a poop just to the right of it, that squirrely thing.
Yes,
It's a
right.
cucumber poop.
Yep.
Interesting.
That's what I
They're
noticed.
actually kind of attached to that. Or maybe they're just stuck in the spines.
Oh,
Not
Ouch.
sure.
that sounds uncomfortable.
Looks like a strawberry.
Yeah,
Let's
it
see.
does.
Maybe we can tell.
Whoa, your zoom is so
It does look a little snared.
Yeah.
And they're not moving, are they?
Well, everything's
It
very
looks
slow.
like a
They are
shrimp.
a little.
Oh, no, it's a cucumber.
It's 2 cucumbers. They're like pigtails.
Urchin.
That's all I got on the Zoom.
Okay, thank you for the
Yeah,
zoom.
thank you.
Okay. I guess. Okay, coming wide.
So Danny, I did look up the arms or the what we call them, the walking things, appendages, and they are hypertrophied tube feet. So they're tube feet that have been modified to be
They
these
are too.
Of the sea pig?
Yeah.
Awesome.
Okay.
walking limbs.
Wow.
And I also learned there are 4 main types of locomotion in, let's see, elasipodid holothurians, the sea cucumbers
Oh,
that
that's a great
we see a
name.
lot of in the deep sea. There's swimming or drifting, active swimming, so that would be more activity or motion to it. Walking, which is what the sea pig does, and then sailing, which is what one type of holothurian does, called Psychropodes, and that one has this, well, a bit of tissue that sticks up behind it like a sail. It's thought that it captures the current.
And we can add to that
Tumbling.
rolling.
Rolling.
Yes.
Nice.
I was just thinking I had this.
Are you talking to us?
No.
No.
No, sorry.
Sorry. Okay.
There has been some question about what's going on the bubble cams. The bubble cam is looking down. It looks like we're getting sort of a sediment cloud from
We're
us.
maybe dragging through the sediment.
Yeah, no, I don't.
I just touched the sediment here. I was
Okay.
playing with the trims and got a little carried away.
I don't know, you
Yeah, I got that.
you
Yeah,
got
I got
it. And then I
Hey, if you
think
guys
the
look at
blurry
Argus
thing at the
right
very
now, there's
bottom
a
is
larvation.
Oh, yes.
part of our front porch, side porch.
Yeah, that's the front porch.
That's the front porch.
Right.
So that's just part of our ROV. It's
Keeping
just
an eye
not
on
in
it.
focus so that you can see past it and focus on what might be in the sediment. The chef could use a shout out, Chef Choma?
How do you spell that?
C-H-O-M-A,
Choman.
Choma.
Choman.
Yes, our chef is fantastic. And for those for asking for the video clip of the trash, I will try to create a photo album for y'all so that educators can use this as a resource. But it will probably be a little bit, so you won't have it tomorrow, but I'll work on it for you.
So it's interesting that the clay is layered, right? Sort of uplifted or
I would guess
What about
more
slumping, coming down?
Mm-hmm.
maybe.
Sheeting down and layering up?
Yeah,
Mhm.
I would guess it like some mud landslide in a way, where it breaks
Uh-huh.
off,
Mhm.
shears, and then a clump of sediment falls down.
I see. So it's just the same layer broken off at different places.
Well, that's my hypothesis
Uh-huh.
as a non-geologist.
Okay. So we're kind of heading up the slope, aren't we? It seems.
Yeah, I'm just taking a little zag here to, I need to move the west a little bit, so I'm higher on the slope than Argus. The boat's crabbing to the west a little bit, so I've come west 25 meters, so I'm gonna do the same.
As we get steeper, we might see some more structure and maybe a little more animal life.
Is our plan to kind of keep going up the slope, going along the edge of this slope,
We will be going along the edge of the slope.
edge of the slope?
Oh, that squat lobster just landed on the sediment there, swimming
Cruising
before.
and
The little white one?
exploring.
Mm-hmm.
He landed there?
Yeah,
Oh,
it was swimming.
swimming.
Oh, there it goes.
there we go.
So they swim backwards.
Oh,
They do.
They do for their fast swimming. I don't know if they have a forward swimming. If you think of something like a shrimp, they can swim forward with their little limbs called the pleopods,
Mm-hmm.
periopods, and then they have their big tail flip as a rapid way to escape. And I don't know if squat lobster have the same.
want to go see that? About 60 meters out.
Ooh,
Sure.
yeah.
What was that?
Right? You think, Erica?
What's that? What's the question?
See on the Mesotech? Oh, yeah. See up,
On the sonar?
yeah,
It's
up
just
front.
noise, then.
Yep.
Something hard?
Could be.
I think it might have been noise. Maybe. See.
We are
It's-
seeing a little more shell hash
Yep.
or
Debris, yes, from living organisms.
Ooh, I got a good adaptation question.
Here we go.
and
Maybe we
I
can
love
run
that.
along this
Ooh, there we
structure.
go.
Yeah.
Copy that.
Shoot, Danny.
All right, what is an adaptation adapted by deep sea life that would be useful in human life?
Can't hear you.
Can't hear me?
Hello,
No.
sorry, I was talking.
Oh.
Gills, but that's not a deep sea adaptation.
I would
that's
love
just
gills.
Things in life, and we have gills during development, and then they close up and we lose them.
How about being able to feel your way around without any light? Like sense your surroundings.
Oh.
I like that.
I think of people who don't have vision, who could benefit from
Yes.
knowing what's around them.
I think that's a great one.
Some people
Fine
have
with
gotten
Spanish.
okay at click echolocation.
Yes, echolocation, that is true.
There's a sea spider picking a gonid again.
Where's that? Oh,
It's
straight ahead.
just straight ahead.
Right.
Uh-huh.
Oh, yeah.
Is this the structure we were seeing, or is it farther away from us?
Hard to say.
The sonar.
I came up
25 meters. You came up 25.
So what is
Yeah, I
that
think
kind
this
of
is probably what we're
flat-looking
seeing.
thing? Do you think that's biological there, Amanda?
What,
Flat
what
thing?
flat?
The,
You mean the sponge?
projection, is that a sponge?
There is a white
Yes.
sponge.
Yes.
Okay.
Yes.
Wow.
Yeah.
So the clay is fairly consolidated.
Enough for lightweight things to live on, I guess. Judging by that sponge and these black corals.
So maybe if we run along this structure and if see if we see some more of it.
Yep.
Picking up some sea stars now. More urchins, cucumbers.
Ooh, there we go.
Yeah.
That's
Is
pretty.
this that anemone you were talking about?
That's a
And
fine-looking
another
anemone.
urchin? Or is
I'm
that-
not sure.
It's pretty.
There's a grenadier.
Yeah, that might be a different species. That is Leptolepis. That is the ghostly grenadier. It's white on the head and it gets darker as you go to the tail. Oh, that's a nice structure up ahead.
Oh, look at the dirty sponge. That's dirty sponge.
Straight ahead.
Mm-hmm. It's a Rhabdocalyptus or similar.
The one there on the
species.
right?
Yeah, just to the left of that pale sea star up on that ridge that's just off screen now.
That's a good shot of the grenadier.
Yep.
Yeah, you see how it's white on the head and then the modeling gets darker on the tail. It's got a more pointy nose than the other ones. We only see that deep in the deep, deep. And we are deep, deep.
We are deep, deep. Last I checked.
The technical term.
See. Our depth is currently 3,224 meters.
Yeah, that's deep. So that there is the dirty sponge.
Can we zoom,
It's
please?
really dirty.
We can definitely zoom.
Go ahead.
You want to hold this distance?
Sure.
Thank you. All right.
We've got another Benthictinophore on the right.
Siphonophore.
Sorry, Siphonophore.
Yes. Yeah, that is a dirty sponge.
Ooh, and another urchin.
So these guys get a bunch of stuff
Sea
growing on the
stars.
spicules that are on the outside of them, so they get coated, then dirty like this. And so yeah, there's a paper that describes
Wow,
the
there's,
spicule jungle around one of these species of glass sponges that has this coat.
Spicule jungle.
So what was
Welcome
that
to the
thing?
jungle.
What's that thing there on the to the left of that whiter sponge? Is that a
That's a Bracingid, isn't
Okay.
it?
I think it's
Or
a
is it
crinoid.
crinoid?
Crinoid.
But
Oh,
Oh, hello, squat lobster.
he wanted to be part of the action.
Photobomb.
Oh, we were told by Mary Wixton, one of our scientists on shore, that she could identify the squat lobsters if she got a good close-up look with, okay, well, maybe we'll have another chance.
so
wide.
lots of urchins.
Thank you for the zoom.
Yes.
You're welcome. Full wide.
Ooh.
Ooh, hello.
Yes. Wow. That is beautiful.
It looks like it's floating.
It might be. So some of these are on a stalk. They sort of get onto an older dead stalk of something else. And we've seen a purple version of this, I believe.
Wow, where is the stalk?
See the dead looking dark thing at the back?
Kind of the back
Okay.
right of it.
I can focus on that.
Oh yeah, back right.
Might not be in here. Might be in the Ridge guide.
Some pretty fine hairs.
Yep.
Yeah, that's the stalk in focus.
Beautiful.
So the benefit of those long, thin tentacles
Going wide. Thank you.
sticking out there where they can
Well,
capture things
They're not
floating
in there,
by.
isn't there?
That?
Oh, that might be it. Bolosira.
Bolosira?
Yeah,
Okay.
that might be it.
I'm going to check
Ooh,
one more
look at
source
Ooh,
now.
another
sea
sea star.
star.
That's
Oh,
interesting.
that looks like a burrowing one.
That is interesting looking.
Yep.
Very different than our cushion ones.
Wow. Yeah. Amazing.
I think one of the scariest things of the deep sea is watching a sea star move really fast.
The sea star gallop.
Yeah.
Look how the arms are curved up and slightly back like that. So
Yeah.
some of the tube feet at the tips of each arm can have modifications or extra, or a different type of cell, a sensory type cell. So lifting their arms up like that is a way that they're sort of sniffing or sensing the world around them. In shallower species, that can be light sensing cells. I'm guessing here they're not light sensing cells because there's no light.
Is that the acorn worm?
It might be. Or spoonworm. What's that coming out of the
Oh,
burrow?
we'd have to zoom. I would love to zoom if we can.
So what is the spoon worm? Is it a polychaete?
It is an annelid. Is it
Okay.
a polychaete? I don't believe so, but it is a polychaete. Blah, blah, blah.
It's an
Ignore what
annelid.
I said. It's an
Okay.
annelid.
Okay.
So it has a coelom?
It does have a coelom. Yep.
Okay.
A coelom is a body cavity that forms during development. Are we working on zooming on that?
It's an echeurean, Dane.
Oh, it's an
A spoonworm
echeurean.
is
Yeah.
an echeurean, which is now
Okay.
within Annelida.
Oh, it is?
No longer its own phylum.
Okay.
Same with Cypocula.
Oh, right. We were talking about that. The fatting keeper.
Yes.
Yeah. Same.
Go ahead. Wait.
All right, zooming in.
Okay.
Okay.
So-
Wow, that is amazing.
Clearly,
And
there's a
so
part of it.
he has a burrow, right?
this
Or
would be
he or
good.
she. Look at that.
Yes.
Don't want us to look at your
Oh.
into
proboscis,
his
do
burrow.
you?
That one can roll its tongue.
Goodbye. Wow, that is
Wait, that's
so
the whole
neat.
thing's a proboscis?
No, that's the body, right?
Right.
I don't think so.
No?
Because it folded itself up.
Yeah, I did.
That was just a flat sheet.
Aha. So spoonworm is somewhere down in the burrow. And it sticks this tongue out and waits for food to drop on it or crawl across it or...
Very neat. Very interesting.
Okay, thanks for Zoom.
Yeah, thank
Okay,
you.
coming.
Yep.
Coming wide.
All right, I've got a quick question. There are people that were wondering about the trash and sort of like ship dumping rules. What are the rules inside a marine sanctuary?
All right, so the sanctuary has several regulations. The main ones are no oil and gas or mineral extraction. That was the major one for getting the sanctuary designated. And there are other things like no seafloor disturbance, unless you have a permit for education or research. You
Yeah,
can't-
and it's not coming up over the top of the machine, right? Yeah, thank you.
Other regulations include you cannot disturb a submerged culture resources, like a shipwreck or an airplane, like our Macon in the southern region.
Which was an airship that went down.
I have confirmed the identification. That was an echeuran
All right.
based on Mbari's deep sea guide.
Okay.
I looked up echeura there and they got
Okay.
it.
The next,
So we were likely seeing the proboscis.
Okay, thank you. And you need a permit to put a buoy out, right? I mean,
yeah,
that's
that triggers the seafloor disturbance
Yep.
regulation. You cannot disturb marine mammals or seabirds unless you have a permit
A
from
little bit
the
of both.
appropriate agencies who manage those. Fishing is allowed in our sanctuary. At Davidson, it's only above 300 feet that you can do fishing. The bottom is protected from bottom gear. We also have a low overflight zone that you cannot fly below a certain altitude to protect nesting seabirds and marine mammals.
And
Oh, I didn't know
I
that.
also know that with permission, you can distribute ashes, human ashes.
Yes,
In the sanctuary.
that is allowed.
Oh.
So otherwise there is no discharge in the sanctuary, so we cannot discharge sewage or dredge material without a permit. So we're trying to keep the
That's
sanctuary
lepidisis?
in its natural state. Look at that long coral.
Very,
Yeah.
very.
Wow.
I feel like it's a-
Zowie.
Got
Ooh.
stuff growing on it. Maybe it was a lepidisis.
Do you guys want to keep this wide view, or do you want me to image that? I can go get some zooms on it and stuff.
We could do some zoom on this
Yeah.
coral. That'd
Yeah.
be great.
And hello, Mike.
Yeah, I mean, look
Hello,
at the
Okay,
in
does
the
it like-
Argus view.
Hold on
That's
a minute, I'll get a bit
big-
closer to
Okay,
it.
okay.
That's a big thing. It's as wider than Hercules.
All right, go ahead in there, Wayne.
Okay. Yep.
Looks like we've got
Look
some
at
anemones on
that.
there. So we have some anemones on the dead parts of the coral, or the corals without tissue. They're residing on the skeleton. But there's some tissue,
But
just
there's
not
some
polyps.
living coral.
Yeah, but It's doing okay. It's not perfect.
Huh. It's
I
got
wonder what it
anemones
It's
growing
doing
on it.
okay, yeah.
Yeah.
I wonder if this is
So this is a bamboo coral. So if you look real close, you'll see some dark segments along the
Yes.
skeleton.
Right. Right.
That's where the internodes are, or the node, where it's able to flex in currents. So it's not a totally hard coral. It can flex with movement.
Huh.
So it doesn't break off, I suppose. And those coral
Okay.
polyps are all out, so it's looking for food.
Mm-hmm.
I've got some good zoom. If you iris down,
Yeah.
we might be able to see a little bit of detail on the polyps. We could look for whether they're full of food or even if they have eggs inside.
Oh boy, we got some at the
Look
tip here.
at that big anemone.
Now the anemones on this coral, are they eating the coral or are they just damaging it by being there, or what's the interaction happening here?
I don't know if it's eating tissue. It's definitely residing there to maybe get out in the water column.
It's a nice shot.
Look how,
Yeah.
well, there are multiple anemones there, and they're wrapped around, you can see how they're wrapped around the shaft of the coral.
Wow.
Amanda, do you
Oh.
think this is lepidisis?
That would be my guess.
Yes, although it has
Is that,
branches.
what
Yeah.
is that? That looks like a golf club.
Behind us,
Oh, yeah.
behind that.
Oh no.
Or it's a dead coral that's dropped over.
Yeah.
You guys can see why this is called an octocoral if you count the number of
Tentacles.
coming off of each of those polyps. There should be 8. Octo, 8. Thank you
Okay,
for that.
coming wide.
And that looks like that is a...
I think it's a fallen coral.
Yep, I think it's a
Fallen
fallen
bamboo.
coral.
Yeah.
Sure.
Sure.
You
Yeah,
can see the nodes, the darker nodes.
that's right.
Yes.
Another bamboo coral.
Not a golf club.
Okay,
And not
thank
a
you.
golf club. I'm
Okay,
glad
coming
of
wide.
that.
This is a nice structure we've got running along the contour.
Mm-hmm.
with a sponge.
Do we know of any viruses that are found in the depths down here?
There are viruses everywhere, so yes.
Yes.
There are a lot of marine viruses. There aren't a lot of people characterizing them. I believe, actually I should check first, but I'm going to say it as I check, that the Tara Oceans Project is looking at viruses as one of the groups that they're characterizing.
Very cool.
And what is that program you mentioned?
Hold on. The Tara Oceans Project.
Who is doing that?
I'm looking it up because
Okay.
I know vaguely what it is. It's a kind of a global survey, but I think it might
Okay.
be. Okay, I'm gonna look it up before I start just guessing. Oh, well, how about a paper
There
that was...
is a Duke University lab studying urchin viruses. I did not know that. And here we have another one, Curtis Suttle at the University of British Columbia in Vancouver for marine virus research.
So have they figured out what caused the sea star wasting disease?
Oh.
They have. It's a virus.
It's a virus.
And the virus is naturally occurring, but the sea stars were thought to be more susceptible to it that year because of warmer temperatures.
Warm temperatures.
So that was coincident with when the blob was resting over the North Pacific, which gave abnormally high temperatures.
And so that whole process has had far-reaching effects because with the demise of sea stars along stretches of the coast, urchins have predominated and mowed all the kelps down, and now you have these large stretches of coastline along the California coast that are urchin barrens. Mostly coralline algae and very little foliose algae. So climate change has unanticipated effects.
So the Tara Ocean Foundation is based in France, but collaborates with researchers from around the world, and it's a floating platform. It looks like it's a sailboat. Floating laboratory, a research, I don't know how to say that word out loud. I've never said that word. Schooner? Schooner?
Schooner.
Okay.
Schooner.
I can't believe I've never said that word, but it's true. So, so they've gone out. They had a 3-year initiative to survey the microscopic diversity. And actually just this year, research from the Tara Oceans Institute was published in May in the journal Cell. It talks about marine DNA viral macro and micro diversity from pole to pole.
Wow.
So there are several researchers on this paper who were studying, viruses in the ocean.
That's pretty interesting.
Yeah.
In regards to the sea star wasting disease, does it affect the sea stars at depth as well as the intertidal ones?
Well, you mean at these depths down here?
I'm going to go with yes.
Probably not, because I don't think the deep oceans have changed that much in temperature. Does anybody know that?
I don't think that's been affected down Davidson Seamount.
Right.
We haven't seen any sea star wasting down here yet.
Right.
At shallower deep depths, there has been a decline. So surveys off of Southern California did not see Pycnopodia, the sunflower star, which is one of the most susceptible to the wasting disease in the last year of surveys at about, I think it was 70 meters or 100 meters.
Wow. Okay.
Okay, so deep, but not
Just not this
deep.
deep.
this deep. Okay.
Still deeper than we can survive.
Sorry? I can't hear you, sorry.
What are your favorite sections of the ocean in terms of depth? Do you guys have favorite ocean zones?
My favorite is the deep sea. Anything below 200 meters,
Aaron,
but
you
I
wanna
like...
increase the scan speed on Argus there for about one more click.
It's like depths below 1,000 meters. Because of the deep sea fishes, the corals, the sponges, kind of what we're looking at today.
I'm kind of with you. I have a feeling that we're biased toward the deep
Tuck
sea
off
on this
chest.
trip.
Oh, it's better, yeah.
Yeah.
So,
Yeah. Go ahead.
could you not hear me when I was talking on pilot, co-pilot? No. No? Interesting.
I
can hear you now.
think that my favorite is